Hello, my name is Chris Fox, and I am a technical lead with the support team here in Redlands, California. My specialties include ArcGIS Desktop, Geoprocessing, and Python. And joining me today is Dave Wynn, who is a product engineer with the Geoprocessing team here in Redlands. He's done a lot of work at the 10.1 release with Python, and specifically our topic today, Python Toolboxes, so he's going to be a great resource for us. So today we're going to talk about and introduce Python Toolboxes, what they are, and why you might be interested in authoring your tools in this way. In the second section, we're going to go into more detail about creating a tool. In our demo, we're going to walk through the process of creating a new tool from scratch. And finally, we're going to conclude with some additional functionality, such as things you should be aware of, additional parameter types that are available with Python Toolbox, and things to just wrap up the presentation. After each topic, we're going to have a software demonstration, and this is where we're going to open up ArcGIS Desktop and show you Python Toolboxes and how you can work with them. And we're going to follow the demo with a review of what we talked about in the slides and an opportunity for some Q&A. So please go ahead and send in your questions during the presentation. We'll do our best to answer as many of them as we can. So what are Python Toolboxes? The toolbox itself is going to be defined by a single text file, and it's going to have a .pyt extension. And that file is going to define the toolbox and its properties. And it's going to define one or more tools, each tool having their parameters, their behavior, and what happens when we actually execute them. And we're authoring this file using Python. And this is going to make creating your Python toolboxes much easier. And the maintenance is going to be easier as well, because we're doing this all in a single file. So why would you be interested in authoring your toolboxes in this way? First of all, for users who have experience in Python, the script tool process is kind of inefficient. For example, we would author our script tool using a wizard, right-clicking the toolbox, going to New Script Tool. We would define the parameters in that wizard. If we wanted to add validation code to our script tool, we would write that in one location, and that code was stored with the toolbox. And we would then write our separate source code, or our code that was run when we would execute the tool. And that was done in a separate file that we would associate with the script tool. With a Python toolbox, we're doing all of these things in one place. They also support additional features. So, for example, something new we have is the ability to check for licenses. And based on that check, determine if a tool is authorized to run. And there's also some additional parameter types that we can create with Python toolboxes. And we'll talk more about those later in the presentation. So for end users working with Python toolboxes, the experience is going to be the same as working with tools created in any other way. So for example, if you've created a model or a script tool or even the system tools, the way you interact with them is going to be the same. You can open them by searching for them and finding the tags associated with that tool, or you can browse to the toolbox in the catalog window, double-click the tool to open it. You can also add these tools into a model and run the tools that way, or import the Python toolbox through code and call the tool from Python. And finally, leveraging the new framework we have at 10.1 for creating geoprocessing packages, we can share these tools as a geoprocessing package, and we can publish these tools as a geoprocessing service. So the experience working with them once they're authored is going to be very much the same as any other tool. So Python toolboxes are defined by classes, and what we mean by that is every Python toolbox file is going to have a single toolbox class, and that class is going to define the properties of the toolbox and the tools that it contains. And so in addition to that, every Python toolbox is going to have at least one tool class. And that tool class is going to have methods to define the properties of the tool, to set the parameters, to have code that's run during validation, and also the code that's actually run when we run the tool. So to create a Python toolbox, all you need to do is right-click a folder in the catalog window and go to New Python Toolbox. This creates a text file with the .pyt file extension, and it uses a default template. And that template is going to define the toolbox and a single tool. So you have the basic structure that defines the Python toolbox available. Then you can add your own code to customize the behavior of the tool. On the other hand, you could just write the code in a text file and rename the file to have a .pyt file extension. You don't even need ArcGIS Desktop to author this. You could author this on a machine and share it with users in desktop. As long as it meets the criteria of having that toolbox class and that single tool class, and everything meets the requirements for those classes, then they can use that toolbox, and you don't even need ArcGIS Desktop to author it. So let's go ahead and jump into the software and take a look at some of these things we just talked about. So what I have here is a map document. You can see inside the catalog window, I have a couple toolboxes here. They're pretty similar, but we see a slightly different icon for this toolbox. This is showing me that this is a Python toolbox. You can see its file extension .pyt. If I expand the toolbox, I have a single tool under there. It looks very much like any script tool I may have authored in the past. I can double click it and I can open the tool. It has the parameters established. I can populate these, same experience. I have the tool help here over to the side. So let's talk about this tool and what it actually is. What I've defined in this tool is some functionality that's come from users that's pretty common or frequently requested. They want to be able to calculate a unique ID for a table based on a sorted record. So they want to sort the table and then calculate a unique ID based on that sort. So I can do that with this tool. What I can do is select the input features. I can select what I want to sort by. So let's sort by subregion in a descending order and population ascending. So smallest to largest population. Then I select the field I want to calculate. And then I have my start value, the first value I want to use, and what I want to increment that unique ID by. So I'm just going to use the defaults 1 and 1. So I can hit OK to run that tool. It's completed. So what I can do is I see this value down here. Let me go ahead and sort this ascending. So what we see is I have the subregion first. So here's all the west-south central subregion, followed by west-north central. And then I have the population sorted smallest to largest. And so I have my unique ID there that was calculated to that field. So running the tool, same experience I always have. I just populate the parameters, click OK to run. If I come into the results, what I can see is, like any other tool, I've created a result. I can get information, the messages, what the inputs were. I can right-click the result and go to Share As a Package or a Service. So I have that same experience with this result. I can, if I have a model, I can edit this model, and I can drag and drop my tool in there. And I could attach this to other tools and use this in an automated way. Again, I could also call this tool from Python if I wanted to automate the interaction with this tool. I can also search for it. So here's some keywords. Here's my tool that I have available when I type in some keywords for that tool. So how do we get started in creating a Python toolbox? Like I said, it's very easy. We can right-click and go to New Python Toolbox. Let's go ahead and give it a nice name here. And I can edit this file by right-clicking and going to Edit. And that's going to open my default IDE environment that I've associated with editing scripts. If I expand this a little bit, what we see is here's my class that's defining my toolbox. Inside, when I initialize this class, I'm going to set some properties. So the first thing I want to update is my alias. So I'm going to call it my toolbox. I'm going to give it that alias. If I save this, come back and refresh my toolbox, I can go into its properties, and I can see that there's my alias that I wrote in the code. That property is being driven by the underlying code. I have currently in my toolbox one tool. If I want to, right now the way that that tool is being referenced is I have a tools property for the toolbox, and that's looking for a list of tool classes. So I have a single tool class inside defined in my Python toolbox, and I'm referencing the name of that class here. If I want to add another tool, what I can do is I could just copy this class. We got to give it a unique name, and I'll give it a unique label. And then I just have to reference that in the properties, the tools property of the toolbox class. So this will be tool 2. I can save it. And when I refresh this, now I have a second tool. I can open this tool. Right now I have no parameters. I haven't defined any parameters in the Python toolbox in that tool class yet, but we're going to walk through that process in the next section. So this was just an example of what the Python toolbox is. We're working with it the same way, and how we can get started in creating the Python toolbox. So in this section, we talked about how the Python toolbox is defined with a single file, and that single file defines the toolbox, its properties, and the tools that belong to that toolbox. It's going to be more efficient for users who have experience with Python because we're doing this all in one place. We're maintaining and creating our code all in that single file. And for end users, it's going to look, act, and work like Toolbox is created in any other way. So there's no learning curve for other users or colleagues that you might distribute these toolboxes to. So now I want to turn it over to Dave, who's going to answer some of the questions that have come in so far.
Hey, thank you, Chris, and good morning to the rest of you. Lots of good questions coming in. I'll try and answer as many as I could. A couple questions related to the tools that Chris has shown. Rosie asked, that sort tool is cool because that published for download. Is it usable in 10.0? All the scripts and code that Chris has will be putting out later. I'll announce that actually on Twitter. If you look up ArcGIS on Twitter, I'll put it up there. In terms of being usable at 10.0, I think the code that Chris had in the execute was all usable in 10.0, although the Python toolbox, of course, itself is only 10.1 and going forward, so that part would not be. A common question we get is, what do Python toolboxes mean for script tools, and will they be going away? Script tools, as you've been created them in the past, are still supported, and if you want to continue to create script tools, that is also still supported in 10.1 and going forward. From 10.1 on, of course, now you can create a script tool or you can create a Python toolbox. John from Long Beach asks, can I convert an existing script tool to a Python toolbox? Yes, of course, the script tool, again, is still supported, but if you want to convert some of your existing tools into a Python toolbox to sort of get a look and feel for how they work, we have a utility online that you can do to get started. If you go to arcpy.wordpress.com, you scroll down 2 or 3 topics, there's a post about a utility that you can do to do this. Now, that utility is not a 100% solution, but it is a starting point. So yes, it will convert your script tools over to a Python toolbox, but there will be a little bit of remaining work to finish it off. Another question, are CHUM files supported for documentation? No, not at this point. So for Python toolboxes, the way you create and write your help is through the item description. So you can right-click on a toolbox or a tool, go through the item description, and then that information is carried forward with your Python toolbox in a series of XML files. Tara from Pittsburgh asks, can I encrypt my Python toolbox? Now, of course, with script tools in the past, there was an option that you could both embed and then password protect your Python script actually inside the toolbox file. With Python toolboxes, there's not a comparable option, so that's not supported at the moment. John from Washington asks, do I need to be an experienced Python programmer to develop these Python toolboxes? Well, really, no more than you would have to be to write a script tool. Really, the The fundamental difference between script tool and Python toolboxes is the writing of the parameter definitions. The validation routines and the execute code is largely unchanged and follows all the same techniques. It's really just a matter of creating that initial Python toolbox file and then writing your parameters. I think at this point I'm going to conclude the first Q&A for now. We'll do a couple more of these, so keep those questions coming in. Chris?
Thanks, Dave. So now I want to walk through actually creating a tool. So we demonstrate one of the tools that I've created, and I want to show you kind of what goes into that and the different aspects of the tool class. So here's the basic structure of the tool class, and you can see several methods that are available for you to add your code to customize the tool's behavior. Now, at a minimum, we need in our tool class to have a definition for the initialization so we can set the properties of the tool, and we also need to have the definition for execute, or what happens when we run the tool. Most tools are going to have parameters, so we're going to want to define those too, but a tool doesn't have to have a parameter, so it's not required. And validation, in addition, it's going to add some additional features to the tool, but it's also not a requirement to do. But we'll talk about some of the reasons why you might want to add some logic to validation. So when the tool is initialized, it's going to get some of the properties that we've defined in the tool class, such as its label, the user-friendly name that shows up in catalog, a description, which is some additional information about the tool. We can specify a category or tool set. So the tool set is a property of the tool, and that's how we can add additional tool sets to our Python toolbox. We can add a custom style sheet, and we can also specify whether our tool supports background processing. This is important because there are some tools in some scenarios where the code can't execute in the background. So we can specify whether our tool supports background processing or not, or if we require our tool to run in the foreground. Parameters are going to be defined in the getParameterInfo method. And the way we're going to define parameters is using parameter objects. And we create parameter objects by creating an instance of the parameter class. And when we define that instance, we are setting properties for the parameter object, such as the name of the parameter, the display name, the user-friendly name that shows up in the tool's dialog, the data type, so is it a feature layer or a raster layer parameter, the parameter type, so is it required or is it optional or is it a derived parameter, and then the direction, is it an input or an output parameter. And to this method, we're going to return a list of parameter objects. So that list is going to be used to populate the tool when we launch it. And so by creating these parameter objects and then returning that list, we're defining the parameters for the tool. Validation is going to be everything that happens before you click OK. And this is important because we can customize behavior of the tool while we're populating the tool. So for example, update parameters is a method that is called whenever a parameter value is altered. So whenever we make a change to the value of a parameter. And we can use this method to customize how parameters respond to user input. For example, if we populate the first parameter based on the value that was entered, we could set a default value for another parameter in the tool. Or we could change the allowable values or the filter for another parameter based on the value inputted into another parameter. Update messages is going to be called after returning from internal validation. So what we mean by internal validation is the geoprocessor's validation. And this is run, for example, to test if data sources exist. It would be an example of an internal validation. But once we return from that validation, we have the opportunity to add an error or a warning message to parameters. The reason we might want to do this is based on a value that was inputted into a parameter, we might want to test it for certain things. And if it fails that test or there's a problem, we might want to add an error or a warning message to that parameter. IsLicensed is one of the new functionality of a Python toolbox that we have the opportunity to test whether licenses exist that we know our tool requires. And this method is just looking for a return value of true or false. And if the method returns false, then the tool cannot be run. What we'll see is a little lock icon on top of the tool. If you attempt to double-click or run the tool, you'll receive an error indicating that the tool is not licensed. And this is useful in scenarios, for example, where I might have a tool that I know some of the functions and some of the logic in the execute requires 3D analyst tools. And I know to execute those tools, I need a 3D analyst license. So I'm going to check in the isLicensed method to see if 3D analyst extension is available. If it's not, then I'm going to return false, and the tool can't be run. If it is, then I'll return true, and that tool can be run. The execute method is going to be run or called after we have populated our parameters, after all validation has been done, and we click OK. And this is what we associate with the script tools that we've authored in the past. This is where the analysis, the conversion, or the data creation occurs. And so execute has arguments for dealing with parameters, so we can get the values of the parameters that have been entered by the user, and we can interact with the messages. So if we want to add a message to the result so the user can see that message, or add a warning or add an error, we can do that using this messages argument. So let's go ahead and go into the software and demonstrate building one of these tools from scratch. So what I have here is another map document. I have my home folder I'm going to create this Python toolbox in. To give you a little background of what I want to do here, one of the common requests I see for a geoprocessing tool is a tool that emulates the behavior available when I right-click a field in the attribute table and select Calculate Geometry. So this tool would be used to calculate values or properties of the geometry to an attribute field. For example, I might want to calculate the length of a line to the attribute for a line feature class, or the x-coordinate of a point to the attribute field. So I'm going to try to create a tool here that can accomplish that. So let's go ahead and right-click and go to New, Python Toolbox. I can give my toolbox a name. And so right now I have a toolbox and a tool. Right now there's no parameters in it. I haven't defined those things. But let's go ahead and edit this toolbox and start adding some of that logic. So here's my toolbox class. First thing I'm going to do is edit some of the properties. So let's call this the Calculate Geometry. Alias, we'll call it Geometry. So I've set some of the properties. Now I want to work on the tool class. Right now the class name is just tool. I'm going to give it a better name, a more applicable name. And this is going to be useful if I'm going to have multiple tools inside my toolbox. It would be valuable to have a nice name for each of the tool classes. Because I've modified the name of the class, I need to update the class name inside the self.tools to calculate geometry. And so this is so that the toolbox knows what classes I've defined tools in. So next thing, I want to set some of the properties for the tool. So let's call this Calculate Geometry again. I could add a description. I could set a property of, can I run this in the background? I'm going to set this to true because my tool can run in the background. There's no requirements that says it has to run in the foreground, so I'm going to allow it to run either one. So now that I've set some of the properties for the tool, let's go ahead and add some of the parameters. I have some code here that I've already written, so rather than typing it out all here, I'll just copy paste this. So what I'm doing here is I'm creating those parameter objects. So first thing, I'm creating my first parameter, by creating an instance of the parameter class, calling arcpy.parameter, and then I'm setting some of the properties for that parameter, such as its display name, so the nice name that shows inside the tools dialog, its data type, it's a feature layer, it's required, so you have to enter something before the tool can run, and it's going to be an input, so it's an input to the tool. Here's another example. I'm creating a field. So this is the field that I'm going to actually calculate that value to of the property of the geometry. And so I'm setting properties again here. Same thing, it's a data type of field, it's required, and it's an input. One additional thing I'm doing here is I'm setting a parameter dependency. And so by doing this, what I'm saying is because the data type is a type field, I'm going to restrict the options that can be selected for that parameter based on the fields that are available in the input. So because I'm writing this line of code, what it's saying is only show fields that belong to the input features. Here's my third and fourth parameter. This is for my geometry property, so whether it's an area, a length, or an X or Y coordinate. The units, whether it's miles, acres, millimeters, this is going to be a parameter that they'll be able to specify that. And finally, the output features. So because this is a derived output in that I'm editing the input, I'm actually modifying a field in the input, I'm adding a derived output parameter type. And this is going to be useful if I need to add it to Model Builder and string it together with other tools. Finally, I'm constructing this list. You can see here's the list of parameters, and I'm returning that list to the method. And by returning this list of parameter objects, this is what's going to be actually used to populate the tool with its parameters. So let's go ahead and save this and go back into my map, refresh my toolbox, and now I can see my tool names updated. I can double click it, and there's my parameters. So I've populated the parameters for the tool. I can select an input, and I can see that now I have a drop down for fields, and so these are valid fields for that input features. This is what I was doing with that parameter dependency. If I change it to my lines, I get different options. So now we have our parameters defined. I want to add some code that customizes the behavior during validation. So here's the three methods that are run during validation. The first thing is licensed. So my tool doesn't require any special licenses. It doesn't require a certain license of ArcGIS Desktop. It doesn't require an extension. So I'm just going to return true to that method. And by returning true, I'm saying that my tool can execute in any scenario. But I could add my own logic here to test for different things, and based on the result of that test, return a true or a false. Next, I have update parameters. So there is some code I'd like to add here. So let me go ahead and copy that over and then talk about what we're going to be doing in this code. So if you remember, update parameters is called every time a parameter is altered or the value's changed. So the first thing I want to do as part of my validation is based on the type of geometry of the input. So whether the input is a point, line, or a polygon, I need to present different geometry properties to the user. So for example, area is a valid geometry property of a polygon, but area does not make sense for points or lines. It's not a valid property. Same with length. Is not valid for points. So I wouldn't want to give that option to the user. So what I want to do is I want to test the input features, test what type of geometry they have, and based on that test, whether they're points, lines, or polygons, present a list of options to the user in the third parameter or the geometry property parameter, so they can specify or pick a property that makes sense for that type of geometry. So first I create some static lists here of different properties that make sense for each geometry type. So here's the ones that make sense for points, Here's the ones that make sense for lines and polygon. Next, I'm going to test when update parameter is called, has a value been entered for the input features? If there is a value, then I want to create a describe object on that input. And using the describe, I can test the geometry type or the shape type to determine whether it's a point, line, or polygon. And if it's a point, I'm going to set the list of the geometry property, the filter, to these list of items. So by doing that, I'm requiring that that user either enter an x coordinate of the point or the y coordinate of the point. They can't select area or length or properties that don't make sense for it. So I've done the same thing here for polyline and polygon as well. Next, based on the property that they select, there might be a type of unit that they would need to enter. So for example, I'm going to allow the user to customize what unit they want to enter when they select area or they select length. But the units that make sense for area don't make sense for length. Like I wouldn't measure a linear distance using acres or square miles. In the same regard, I wouldn't measure an area with just meters or yards. I would want to do it in square meters or square yards. So the way I'm going to do that is, again, I'm going to test here to see, has a value been entered for the geometry property? So if there has been a value and that value is area, I want to set the filter list for units to be equal to units that make sense for area. If the property is either length or perimeter, I want to set the list to units that make sense for linear measurements. Otherwise, if it's not one of those things and it's an x or y coordinate, I'm going to clear the value for the units. I'm going to disable the list, set it to an empty list, and I'm going to disable the parameter because I'm not going to have the user enter any units. I'm just going to ask that when they specify an x or y, I'm going to use the units that are defined by the spatial reference of the geometry. So let's go ahead and save this and show you how that works in the tool. If I refresh this and open my tool, I can go to my cities, which are points, and I can see the properties available here are x or y of the point. If I select rivers, I can see now I have different options that make sense for that type of geometry, which are lines. And finally, if I go to my states or my polygons, I have different options that make sense for polygons. If I select an x coordinate, then my units are disabled. I don't have to enter anything, and I don't want the user to enter anything. But if I select area, now I have units available, and these units make sense for measurements of area. If I switch to perimeter, I have units that make sense for linear measurements. So that's what I did in my validation code and what I called from update parameters. Another thing that I might want to add in my code is messages based on what's input to a parameter. So I have some code here that I want to run in update messages, so let me go ahead and add that. So if you remember, update messages is going to be called after the geoprocessor returns from internal validation. And what we might want to do in this scenario, and what I'm going to do, is if a user has entered either length, perimeter, or area, I need to require that they specify a unit. Because the parameter is optional, and it needs to be optional because in scenarios where they specify a property that's an x or a y coordinate, I don't want them to enter a unit. If they have entered one of those that I do require a unit, I'm going to test to see if they've selected one of those properties and the value for the units parameter is not populated, or it's null. If it's empty, then I'm going to set an error message on that parameter and let the user know that units are going to be required for this type of property. By doing this and setting an error message, I do two things. One, I give them an informative message that they can use to resolve the problem before they run the tool. And two, by adding an error, you're not allowed to run a tool while an error exists on a parameter. And so I'm forcing the user to resolve that error before they run the tool. And I think that this is a better user experience rather than allowing them to run the tool and having it fail while the tool executes. So if we add this error, give them information about how to resolve it, and then allow them to resolve it before they run the tool, it should be a better experience. So let me go ahead and show you that behavior. If I refresh this toolbox again. So let's enter some polygons. Let's select X coordinate. Right now, if I populate all the fields, I could run this tool. There's no errors. I would be able to run this. If I select area, what I see is this icon. If I click it, I can see that there's an error associated with it. It's saying that the units are required for that property. If I tried to run this tool, it would prompt me with an error, and I would not be allowed to run this tool until I resolve it. Once I select a unit, now the error is removed, and I could run this tool. If I switch back to an X or Y, that value is cleared out and the parameter is disabled. So that's what I am doing there with update messages. So last thing we need to do is actually add the logic for what happens when we execute this tool. So let me go ahead and copy that code over and put it down here in the execute method. So when we execute the tool, the first thing I'm doing in my code here is I'm getting reference to the values in the parameters, so what was actually entered by the user. And I can use these variables later in my code. Next thing I'm doing is I'm getting a reference to the name of the shape field. And the reason I'm doing that is what is actually going to happen in my code is I'm going to use the calculate field tool to create an expression that calculates a property of the geometry based on the user input. So using the shape field, I'm going to create this expression. And I'm going to test what type of property they're using. And because I have some control and field calculations, I can get properties like area or length of a geometry by saying shape field dot area. And I can use some of the modifiers to specify what unit I want to return. Or this is my logic to create an expression that's going to be used for the X or the Y coordinate. Once I have my expression, I'm going to use messages to actually add a message to the result that tells me what expression I used in my field calculation so that I can present back to the user. This was the actual expression that was passed to the field calculator. And finally, I'm just going to call calculate field. I'm going to pass in my input features. I'm going to pass in the field that I want to calculate this value to, the expression I'm using, and the parser that I want to use. So let's go ahead and save this and refresh my tool. So let's start with our points. Let's select the cities. I'm going to calculate this value to that calc field. And let's calculate the Y coordinate of the point and run this tool. So you can see here is that message that I added. I'm saying the expression that I used, shape.firstPoint.y, and you can see that that field's been updated with the Y coordinate. If I come to my lines, let's go ahead and calculate to the calc field. Let's calculate the length, and let's do it in kilometers. Calculate that value. There's the expression I used and the result returned in kilometers. And finally, I can do the same with my polygon. Calculate into that field. Let's go ahead and do area, and let's do it in square miles. There's the expression that I used again. The field's updated and updated with the results from the square miles. So this was an example of leveraging a lot of the functionality that we've been able to use in the past with script tools, but authoring all of that in one location. Setting the properties for the tool, setting up the parameters, adding some validation code to customize the behavior while we're working with the tool, and finally adding our logic for what actually happens when we execute the tool. So the tool class is going to define the tool and its behavior. And the validation is going to be everything that happens before we press OK, that we can customize some of that behavior to the user. And execute defines what happens when we run the tool. So now I want to turn it over to Dave to answer some of the questions that have come in so far.
All right, thanks, Chris. Courtney asks, from Chesterfield asks, can tools within a Python toolbox be grouped in tool sets like in regular toolboxes? Yes, they can. So the way you do that in the tool class inside the init method, you just set self.category to the name of the tool set, and then when you come back into the application, refresh, it'll be organized into a tool set with that name. Suda from Lafayette asks, can a tool created using a Python toolbox be accessed via schedule tasks to be set to run automatically? Yeah, so the way you would do this is once you've created your Python toolbox, you would create a separate script that would import ArcPy, then call arcpy.import toolbox, the name of the toolbox you just wrote, and then you would call the tool, and then all you have to do is set that py file to run through the task scheduler. Naresh from Kansas City asks, are there any good books on Python for ArcGIS? So yeah, when you look for books regarding Python, usually it's all strictly Python as terms of the standard libraries and sort of core Python programming. There aren't really a lot of books out right now that deal with ArcGIS and Python, but there is one expected to be released out by ESRI Press, I believe in January, February of 2013. Leroy from Decatur asks, how would you provide a brief help topic for each parameter? So the way you build help for Python toolboxes and tools is through the item description. So you wouldn't build a separate topic per se for the parameter, but the parameter information could be defined through the item description, and then you will see that when you're looking at the side panel help for the tool and the parameters, or if you click on the help button, it would launch up a help page with all of the help information for that tool, including the parameters. Lynn from Providence asks, my new script tool has its edit function grayed out. How do I associate it with a program to edit? So if you're working with a Python toolbox, you won't be able to edit directly off of the tool in the Python toolbox. You won't only be able to edit off of the top node or the Python toolbox itself. Now, if you were dealing with a script tool and you see the edit function grayed out, that usually means that the source for the py file hasn't been written in. So you reopen the properties for the tool, go to the second tab, and fill in a py file or other file type at that point. Eric from Port Orchard asks, is this a lead into the eventual migration to Python 3? Well, not in a direct sense. There's nothing about Python toolboxes that are leading the way or blazing the path for going to Python 3. Python 3 is an eventual possibility that we could migrate to, but it requires on a series of dependencies, including, like, for instance, the NumPy site package, which at the moment does not have is not released for 3. It's just in the 2 series. Miri asks, can I obtain this video training? So yeah, after this is finished today, a video of this session will be recorded and posted and should be up within a few weeks. Wendy asks, can you use a Python toolbox in 10.0 even if you can't create one in 10.0? No, not at this, well, no. See, everything about the Python toolbox is designed in 11 or 10.1, so if you happen to take that tool back, it would not be recognized by ArcGIS 10.0. Tammy from Houston asks, do you think it's a good practice to export Python scripts via Model Builder as a starting point for new developers? I have some mixed feelings on that. Actually, usually the exporter from Model Builder to Python is very literal and does not necessarily do everything you need to write a good script. I think for sort of a migration point from Model Builder to Python would actually be to save the tool in Model Builder, call it from Python, and then build a little bit of extra functionality around that. I think at that point I'll turn this back to Chris, and thank you.
Thanks, Dave. So now I want to finish up with some additional functionality here, things to be aware of when you're authoring your Python toolbox, things that are going to help you resolve potential errors, additional functionality that's also going to be involved in terms of new parameter types. So because we're authoring these in a file and we're using Python to interpret the syntax, there could be syntax errors in the .pyt file. And if there are syntax errors, we aren't going to be able to leverage the code in the toolbox until those errors are resolved. So if you browse to a Python toolbox in catalog and a syntax error is encountered, you're going to see a red X icon over the Python toolbox. You can right-click the toolbox and click Check Syntax, and that's going to pop up a window that's going to give you the syntax error, which will have information about the error and also the line that that error occurred on. And from that window, you can click Edit Toolbox, and it will pop open your IDE or wherever you're editing Python scripts, and you can go to that line, resolve the error, save the changes, and refresh the toolbox. And as long as no additional syntax errors are encountered, then you should be good to use the toolbox. In addition, when a toolbox is expanded, we initialize some of the properties of the tool. So, you know, that initialization method, we get information about the parameters. If there's an exception that's raised during that process, and because there was a coding error in the tool class, you're going to see a red X over the tool, and you can right-click that tool and go to Y. And that, again, is going to bring up a dialog that will print the exception, so it will have information about the error that was raised and the line that that error occurred at. So again, you can click Edit Toolbox, you can jump to the line that that error was raised at, resolve the error, save the changes, and refresh. And as long as no additional errors are raised, you'll be able to use that tool. So some helpful things to help you find and resolve some of these errors. So we talked about earlier some additional parameter types. One of the new things you can do with Python toolboxes is create a composite data type. And a composite data type is a parameter that accepts multiple data types. So I could create a parameter that accepts either feature layer or raster layer. And then as long as myself as the developer can, in my execute code, handle for either of those parameter types, I can allow the user to enter either one without having to maintain separate tools to do that type of work. I can also create a value table. So a value table is going to be a collection of columns and rows. If you remember my first demo where I demonstrated the sort and calculate tool, where I sorted a table and then calculated a unique ID, that sort parameter was actually a value table. So it took multiple fields, and then corresponding to each field was a sort method, whether I wanted to sort ascending or descending. And so using that type of parameter, I can get the values from the user and add that to my logic in my execute code to add some to create some or do some special analysis. Finally, if I have a tool that exists, it might be a system tool or a tool that I authored that has a parameter that I'd like to use in my Python toolbox in one of my tools, I can actually get a reference to the parameter object in other tools and return that to my tool in my Python toolbox. So if there's a parameter in a system tool, I can just get a reference to that parameter using that tool and an index to the location of the parameter. I can return that parameter object, and now I have access to that parameter inside of my tool. In terms of documenting tools, we talked a little bit about this so far in some of the Q&A, but the process is going to be the same as you've done in the past for any model or script tool. What you can do is you can right-click the tool, go to item description, and you can edit that item description. So you can add an image to associate with the tool. You can add some tags. This is going to be useful if you're going to index or you want your tool to be searchable. You can add some usage information, so why and what scenarios might I want to use this tool. And you can add some of the dialog explanation. So in that tool side help, when I click a parameter, I want to add some of the help, I can edit that in the item description. this documentation, this metadata, is going to be stored in XML files alongside the Python toolbox. So this is where that content, that help, is going to be stored. So it's definitely good to document your tools. If you're going to be sharing these with colleagues or other users, having this type of documentation is going to make it easier for people working with your tools. And finally, in regards to organizing tools, the entire toolbox can be written to one file, and that's the way we've really been presenting it so far in this demonstration. But there might be scenarios where it makes sense to organize your code into multiple files, multiple Python scripts or modules that you import into the Python toolbox, and you call logic from those imported modules. So for example, if I have some logic that I'm consistently using in lots of tools, I might define that function in a supporting Python script, import that module, and call that function inside of my Python toolbox. It's just another way to organize your tools. It's, it depends on your scenario, but it can be done. So let's go ahead and jump into a demonstration here. I want to focus on finding and resolving some of those errors, and also demonstrate one of these new parameter types that I talked about. So first thing I see here in the catalog window, you're going to see this icon. That is indicating that there's a syntax error in the Python toolbox. What I can do is I can right-click and go to Check Syntax. I see this window that says that there's an indentation error, that there was an expected indent at line 13. So if I go ahead and edit this toolbox, expand it here a little bit, and let's go ahead and jump to that line. So line 13, I can see here that I've defined a method, but the next line is not indented. This is a problem with Python syntax, and indentation is very important. So I need to just go ahead and indent this line. This is another value of working in an IDE for Python, because most IDEs for Python are going to have some tool to check syntax. So it's always good practice to go ahead and check syntax before you close it out. So I saved it. Let's go ahead and close this out. If I come back here and refresh, I can see that that error has been resolved, and now I have access to that toolbox. If I expand that, I can see that there's an error associated with the tool now. So I can right-click that and go to Y, and I'm going to see the exception that was raised when we attempted to initialize that tool. We're going to see that at line 25, it's saying that this global name input files is not defined. So that's generally means I might have a typo or something. I'm trying to use a variable that I haven't defined yet. So let's go ahead and edit the toolbox. Let's expand this a little bit, and let's go to that line 25. So here's that line. I'm seeing that this is where I'm defining my parameters, and I'm returning that list of parameter objects. I defined it, though, earlier as input file. So that's the difference. I have an extra S here, so it's not referring to the right variable. So I can go ahead and make that change, save it. Let's close out of here, refresh, and now we can see that my tool is available, and I can use that tool. So let's go ahead and open up this tool, and what you're going to see is maybe slightly different experience than you're used to. Here's a parameter that has a radio button that allows me to toggle between different values. This is actually a composite data type parameter, and this tool takes layer files or ArcMap documents. And what the tool is going to do is it allows me to enter one of those data types and report whether it has a broken data source or multiple broken data sources. And I know that a layer file can have broken data sources, as well as a map document could have layers that have broken data sources. So it makes sense to have a composite data type parameter here. So let's go ahead and edit this and see how I did that. If I come into the toolbox. So to set up a composite data type parameter, instead of just setting the data type property equal to a string representing that data type, I'm setting it equal to a list of multiple data types. So in this case, a layer file or an ArcMap document. Very simple to set that up. Now in my execute, what I'm doing is I'm testing to see whether that data type's a layer. If it is, I'm returning a layer object. If it's a map document, I'm going to create a reference to a map document object. And then the good thing in my code, this list layers function takes either a layer or a map document object. It works on both. So the code doesn't have to be written specific to each of those. And then I'm just testing if the layer has any broken data sources. And if it is, I am adding a message indicating that there's a broken data source and what the layer name is. So let's go ahead and run this. So here's my layer file. Add that. Run it. I can see here that it's indicating that there's several broken data sources. This was a group layer that had multiple layers. I can do the same thing for a map document. Go ahead and select it, run it. Again, broken data sources for that map document. So this was just an example of leveraging a composite data type to accept multiple types of data for scenarios that make sense. And this logic makes sense to either select a layer file or a map document. So in this section, we talked about how errors are identified for you, syntax or exceptions that are raised when a toolbox or a tool is initialized, and how you can resolve those. The Python toolbox supports some additional functionality, like the composite data type and the value table parameters. And you can document these tools like any other tool using the item description. So now I'm going to turn it over to Dave to answer, have the last round of the Q&A.
All right, thanks, Chris. Yes, Cameron asked, do I have to be a master in Python first for creating these tools? No, I don't think so. I think as long as you can do a little bit of Python code, you can do a Python toolbox. The main part for the Python toolbox is really what's inside the execute code. And that really is up to you, right? Any little bit of code you want to turn into a tool, or anything, more sophisticated, all those parts can be wrapped up inside the Python toolbox. The rest of it is really just a little bit of framework to get you on your way. Heather asks, and this is from Colombia, and this is a reference to one of my earlier answers. My organization blocks Twitter. Is there another place you could post the presentations and the scripts? Yeah, Chris will have these up in the coming weeks, and I think we'll make reference to this on the Resource Center. So you go resources.arcgis.com, you go to Python, we'll get that information on there when it comes up. Another question I've seen a couple times is, how do I create a feature set parameter in a Python toolbox? Well, a feature set parameter is defined like any other parameter inside of get parameter info by creating a parameter object. The key part, though, is to get the parameter to work with and interact inside of, say, a map, is to point the value property to a layer file. And that defines all the symbology and schema needed and used by the parameter. Another question is, how can I find files that are relative to my Python toolbox? So in some places, for instance, like the feature set parameter, or other cases, you'll need to be able to find a file that sits relative to the Python toolbox or the PYT file. The best way to take care of this is you can take advantage of a global Python variable named _file_. In a Python toolbox, this will return the path name to the PYT file. So then you can then use methods, say, in Python's os.path module to create file paths relative to that location and find those files. If you're looking for additional examples of Python toolboxes sort of in the short term, there's a few that I posted that you can get to through some short links. So if you go to esriurl.com/Python or PYT1 or PYT2 or PYT3, these are functional examples of Python toolboxes that are up and you can use on your 10.1 install today. At this point, I'll turn it back to Chris. Thanks for all your interest today.
Thanks, Dave. So before we go, I'd like to point you to a few additional resources. What we've introduced today is a framework for authoring tools with Python, but really where the power of these tools is going to come in your logic, what you're adding to the execute method when it's run, what you're adding during validation. And having powerful tools is going to need to have some experience with Python and the ArcGIS site package. And so these are some courses that are going to give you more introduction into Python and specifically Python with ArcGIS. We also have the help topic, creating tools with Python, which is going to go much more in depth into what we talked about today. How do you author your tools? What does it mean in terms of validation, and where do you add your code when it's executed? And finally, we have a training seminar, creating desktop add-ons using Python, that we provided earlier this year. That's going to give you an introduction into Python add-ins, adding functionality to interact with the user environment, and adding your Python logic to it. Your comments help us improve our seminars. Please take a moment to complete our survey. Just click the Give Us Feedback link to take the survey. We hope you enjoyed today's seminar. On behalf of ESRI, I'd like to thank you all for attending.